So, hello everyone. In this lecture, we are going to learn about the properties of conjugate of complex number and properties of argument of the complex number. Okay. So let's get started. First, we'll learn properties of conjugate. See, the first property of conjugate says that if the complex number, if you will add with the conjugate of that complex number, the complex number and the conjugate of that complex number, if you will add, you will get two times the real value of two times the real part of the complex number z. Got it? Why? What is a complex number z? Complex number z is x plus iota y. X plus iota y. So what is this z bar? Z bar will be x minus iota y. So minus iota y and the plus iota y will get cancelled. The imaginary part will get cancelled, and we will get here 2 times x, which is 2 times the real part. Got it? Any doubt? Now the next property says that if we will subtract, if any complex number z, if I'll subtract with its conjugate z bar, z minus z bar will give 2 times the imaginary part of z. That means 2y will get, in this time, what will happen? The real part will get cancelled and will get 2 times the imaginary part. Got it? Now, can I say that z plus z bar is purely real? Because the imaginary part got cancelled and the imaginary part is 0 thus. So purely real. What is z minus z bar? Z minus z bar is purely imaginary. Got it? Now next property. The property third says that if z1 plus or minus z2 is there and there is a whole conjugate, then this conjugate we can distribute over sum. Actually, this we can't do in the case of modulus. Understood? This we can do in case of conjugate. This conjugate we can distribute. So this bar I'll write z bar z1 bar plus or minus z2 bar. This is a very important property. We'll use many times. The fourth property says that if z1 and z2 are in multiplication, z1 and z2 whole bar will be equal to z1 bar multiplied by z2 bar. This conjugate we can distribute over z1 and z2. Fifth, if z1 divided by z2 is there and they want the conjugate of the resultant complex number, which we got after dividing z1 and z2. So this we can find by individually finding their conjugate. First we'll find conjugate, z1 conjugate, then we'll find z2 conjugate, then we'll divide. We'll get the same answer. Means this conjugate we can distribute over division also. Understood? Now next, sixth property. The sixth property says that z multiplied by z conjugate is magnitude of z whole square. If we'll see this property, what is z? Proof of this property. This property is important. What is z? Z is x plus iota y. What is z bar? Z bar is x minus iota y. Got it? So if we'll multiply both of them, we'll get x square minus iota y square. What is I square? I square is minus 1. So here we'll get x square plus y square. Got it? In right hand side. Sorry, in left hand side. In left hand side. If we will see right hand side, they have given modulus of z whole square. What is modulus of z? Modulus of z is under root of x square plus y square whole square. So here we'll get x square plus y square in my right hand side and x square plus y square in left hand side. So hence proof. This property is important. Z into conjugate of z will give modulus of z whole square. Got it? Now next, seventh property. Seventh property we'll write here only. Seventh property says that, we'll write seventh property, that if we'll do modulus of z, if we'll do, seventh property says that if we'll do conjugate of z and then again we'll do conjugate one more time, so we'll get the complex number z only. So conjugate of z, conjugate of z will give z only. If 2 times we'll do conjugate, we'll get again z. Understood? So these are the 7 properties of conjugate. Properties of conjugate are important. Using these properties, we will solve questions. Okay. So before solving the question, we'll learn properties of argument also. There are only 3 properties in case of argument. The 3 properties we'll learn, then we'll jump into the questions. Now, properties of argument. See, properties of argument are similar to properties of log. It is same as, you can remember as same of log. The properties of argument are same as of log. Suppose they said argument of z1 multiplied by z2. The argument of z1 multiplied by z2 is argument of z1 plus argument of z2. If I'll say argument of z1 divided by argument of z2, so here this is equals to argument of z1 minus argument of z2. Next property, third one says that argument of, if z to the power n is there, so what will happen in log? This power will become multiplication. Got it? Similarly in argument also, we'll get n multiplied by argument of z. Got it? Now in this properties, these are the properties of argument. Here one more term will come. Here we'll be used to write plus 2n pi also. What is this 2n pi? This 2n pi is also known as correction factor. Correction factor. What it is used for? See, suppose they ask the argument of z1 multiplied by z2. Here they're asking the argument of resultant, right? After multiplying z1 and z2, what is the argument of the resultant complex number? This we can find by adding the argument of z1 and adding the argument of z2. But if suppose they ask principal argument, we know that the principal argument is from minus pi to plus pi. Minus pi open, plus pi closed. Understood? If it crossed plus pi, so we will use this 2n pi as a correction factor to reduce or to increase the argument, so that we get the argument in our range. Suppose the argument is more than pi, so we'll keep here n as minus 1. And we can keep n in here, minus 1, 0, 1, 2, 3. Got it? Similarly, here also we'll multiply with 2n pi. Why will multiply 2n pi? As a correction factor. If the argument by using this formula is not in range, 2, if it is in range, no need of this 2n pi. That means n will keep 0. Understood? Now next, here also we'll use 2n pi. N variable we already used, right? So here I will write some other variable, 2k pi. These all are correction factors. In questions also we will see how to use this correction factors. Okay, these correction factors are used whenever we are not getting our argument in the required range. Then we will use this correction factors to make our answer within the range. Understood? So now next we will see the locus problems based on the argument first. So here, before that, one more thing. If suppose I have written a complex number z is 0 plus 0 iota, that means z is nothing but origin. So z is nothing but origin. So for origin, we will see first what is the argument of, what is the modulus first of all. What is the modulus? Modulus is nothing but under root of 0 square plus 0 square, which will be 0. So modulus of z is equals to 0 plus 0 iota is 0. And the argument of z in this case is not defined. Got it? So z is equals to 0 plus 0 iota means origin is the only complex number for which argument is not defined. For remaining all complex number, my argument is defined. Understood? Now next, now we'll see this problem. See. Now we have seen whenever they have given that modulus of z is equals to 3. What does this represent? This represents infinite complex number, right? This does not represent one complex number. This represents all the complex numbers whose modulus is 3. Got it? So it represents a circle with radius 3 and the center at origin and radius is 3. Similarly, if you will see here, argument of z is equals to pi by 3. This does not represent a unique complex number, right? It represents all the complex number whose argument is pi by 3. That means 60 degree. So if you will try to draw all the complex number, so all the complex number will lie on this line. All the complex number will lie on this line. See, or to be precise, this does not represent a line, because if I will say this represents a line, so line we can produce in both the directions. So any complex number which is on this side, means on third quadrant, we have to measure the argument like this. We have seen how to measure the argument. So this will be the argument of any complex number which lies in the third quadrant. So the complex number has to be in first quadrant, because here they said the argument is pi by 3. So this is pi by 3. All the complex numbers lying on this line, the argument is pi by 3. Or to be precise, we will say that this is not a line, this is a ray. This is a ray. Here there will be a hollow circle on the origin. As I said, the argument of origin is not defined, so we will not take origin point. Understood? And all the points on this ray is having argument as pi by 3. So whenever this kind of statement is there, that means this represents a ray. This represents a ray which is making pi by 3 angle with positive x-axis in anti-clockwise direction. Now next, so what is the locus? Locus of z will be a ray. A ray. Okay. Now next problem we'll see. Suppose this problem. Here also they have given only argument they give. They didn't give modulus. Okay. So here also the z represents a ray. This z represents a ray. If I will draw on graph where this ray will originate, this ray one end point is at 1 comma iota. This I can write as z minus of 1 plus iota. Argument is equals to 3 pi by 4. This only I can write like this. Got it? So from where it will originate? It will originate at the point 1 comma 1. Suppose the 1 is here. So 1 comma 1, it will originate at the point, this point 1 comma 1. And there will be an open circle. Here we'll get an open circle. And what is the argument? Argument is 3 pi by 4. So argument is 3 pi by 4. So the ray will be like this, making the angle 3 pi by 4. 3 pi by 4. So this represents a ray originating, or we can say originating or having one end point at 1 comma 1 and making an angle 3 pi by 4 with positive direction of x-axis. Got it? Locus of z is a ray. Next, this question if you will see, what is the one end point? One end point of A will be 2 iota. So here we'll draw this y-axis, x-axis. This one we can write as argument of z minus of minus 2 iota is equals to minus pi by 2. From where it will originate? It will, one end point will be at minus 2 iota. So minus 2 iota will be somewhere here. 0 comma minus 2. Got it? And how the ray will look like? The ray will have one end point here, and next the argument is minus 90 degree. So here if I will draw, this is positive x direction of x-axis, and with this in clockwise direction. So this will be the ray. This will be the ray. This is my ray. Follow circle at 0 comma minus 2. Got it? Now next, see here they have given both things. The modulus of z they have given 2, and means both condition has to be satisfied. We will take intersection. Z is equals to the modulus of z they have given 2, and argument of z they have given pi by 6. So here modulus of z is equals to 2 means it will represent a circle. Got it? This also represents infinite complex number. This also represents infinite complex numbers. Got it? This also represents one locus. This also represents one locus. But here and they are given. That means we have to take the intersection point of that locus. So we'll see. So z is equals to 2. Mod z is equals to 2 means it will represent a circle with radius 2. So we'll represent a circle with radius 2 and center 0, 0. Now next, argument of z is equals to pi by 6. That means this will represent a ray. This will represent a ray with argument pi by 6. Now what is the intersection point of both of them? This white circle represents this condition. This pink line represents this condition. So now we'll check how many intersection points are there. There is one intersection. So this is my required complex number z. Got it? What is the coordinate of this point? The coordinate of this point will be, for this point, the modulus is 2 and the theta is, the argument is pi by 6. So if we will draw, we'll get the y coordinate as 2 sine pi by 6 and x coordinate we will get 2 cos pi by 6. So this complex number we will get here is 2 cos pi by 6, cos 30 degree. Cos 30 degree is root 3 by 2. So 2 into root 3 by 2 is root 3. And 2 sine 30 degree means 1. The required complex number z is equals to root 3 plus 1 iota. So root 3 plus iota is my answer for this question. Got it? Here the student does mistake is that they will assume this argument of z is equals to pi by 6 as a line, and they will give one more answer which is lying here, but this is incorrect. This always represents a ray in one direction only, not in both the directions. If I'll take any complex number here, the argument will be different. The argument will be negative of something, 90 plus something. Understood? It will be completely negative. Argument will be negative. Got it? So it represents only a ray. That we have to remember. We'll solve more problems in next lecture. So thank you everyone. We'll meet in